Hey everyone, and welcome back. Today we're going to do a deep dive into something I know a lot of you are thinking about, how to start a career as a Java backend developer in 2025.
It's a fantastic goal. And the good news is Java is not going anywhere. In fact, it's evolving to meet the demands of modern applications. So it's really exciting.
Okay, so let's map out this journey. What is the first landmark on this roadmap to Java backend mastery?
Well, you can't build a skyscraper without a solid foundation, right? So for Java development, that foundation is a deep understanding of the core fundamentals. We're talking about things like syntax, data types, control flow, like the basic building blocks of the language.
Right. It's like learning the alphabet and grammar before you can write a novel. But I think a lot of folks get intimidated by just the sheer amount of stuff to learn when they first look at Java.
It can seem overwhelming for sure, but you don't need to become a walking encyclopedia overnight. Focus on mastering the core concepts one step at a time. For example, understanding how to work with different data types is essential for manipulating information effectively in your code.
So what comes after you've got a handle on the basic syntax and data types?
That's where things get really interesting. We start diving into the world of object-oriented programming, or OOP. This is a paradigm that's central to Java and really changes how you approach building software.
OOP is like the blueprint for organizing your code, right?
Yeah.
I've heard people talk about classes and objects, but I'm still a bit fuzzy on how it all works in practice.
Think of it this way. OOP allows you to create reusable components of code, like building blocks, that you can then assemble in different ways to create complex applications. Each object is an instance of a class, and the class defines the object's properties and behaviors. This makes your code more modular, flexible, and easier to maintain.
Okay, that makes sense. So if I want to build a banking application, I could have a class for account with properties like account number and balance and methods for things like depositing or withdrawing money.
Exactly. And the beauty of OOP is that you can then create multiple instances of that account class to represent different customer accounts, each with their own unique data and behavior.
Ah, I see. So OP is all about making your code more efficient and organized by creating these reusable blueprints. That's pretty clever.
And it gets even more powerful when you start exploring advanced OOP concepts like inheritance and polymorphism, but those are topics for another deep dive.
Okay, we don't want to overwhelm folks. So
Sure.
you've got the basics, we've got OOP. What else is crucial in this foundation building phase?
Exception handling is a big one. Think of it as building safeguards into your code to handle unexpected situations. It's like having a contingency plan in case something goes wrong.
Yeah, like when a user enters invalid data or a network connection fails, you don't want the whole application to crash just because of one little hiccup.
Exactly. Robust exception handling is essential for building reliable backend systems that can gracefully recover from errors. It's a skill that will make you stand out as a developer.
Okay, so we've talked about syntax, data types, OOP, and exception handling. Is there anything else we should pack into our Java fundamentals toolkit before moving on?
Oh, absolutely. The Java Collections framework is indispensable. It provides a set of pre-built data structures like lists, sets, and maps that make working with collections of data much more efficient.
So instead of reinventing the wheel every time I need to store and manipulate a list of items, I can use these ready-made tools from the collections framework.
Precisely. It saves you time and effort and ensures that you're using well-tested and optimized solutions.
That's fantastic. And I've heard whispers about generics and lambda expressions. Are those part of the fundamentals too?
They are, and they're becoming increasingly important in modern Java development. Generics allow you to write more type-safe and reusable code by parameterizing types, while Lambda expressions provide a concise way to represent anonymous functions.
That sounds a bit more advanced. Can you give me a simple example of how generics or lambda expressions might be used in a back-end application?
Sure. Imagine you're building an e-commerce platform. You might use generics to create a generic data structure that can hold any type of product, like books, electronics, or clothing. This makes your code more flexible and reusable because you don't have to create separate data structures for each product type.
That's a great example. So it's like having a container that can adapt to hold different types of items without needing to be redesigned each time. And what about lambda expressions?
Lambda expressions can simplify your code by allowing you to pass behavior as arguments to methods. For instance, you could use a Lambda expression to define the logic for filtering a list of products based on certain criteria, like price range or category.
Ah, I see. It's a way to encapsulate functionality into these little snippets of code that can be passed around and reused. That's pretty powerful.
It is, and mastering these concepts will definitely make you a more efficient and versatile Java developer.
Okay, so we've laid a solid foundation with Java fundamentals. but I'm eager to start building real-world back-end applications. What's the next step on our roadmap?
That's where the exciting world of Java backend frameworks comes in. Frameworks provide a structured environment and pre-built components that make it easier and faster to develop complex applications. Think of it like having a set of power tools that help you build your software faster and more efficiently.
Sounds like just what we need. But I've heard that the Java ecosystem is huge. Are there any particular frameworks that are essential for aspiring back-end developers to learn?
Well, there are many great frameworks out there, each with its strengths and weaknesses, but for those starting out, there's one that stands out as a must-have, the Spring Framework.
Ah, Spring. I've heard so much about it.
Uh,
Why is it so popular in the Java world?
Spring has revolutionized Java development with its focus on simplicity, modularity, and testability. It offers a wide range of features that simplify common tasks like dependency injection, web development, data access, and security.
So it's like a Swiss Army knife for Java backend development.
That's a great analogy. And one of the key reasons behind its popularity is dependency injection, or DI. DI allows you to decouple the different components of your application, making your code more modular and easier to test.
I've heard DI mentioned a lot, but I'm still a bit unclear on how it works in practice. Can you give me a real-world example?
Sure. Imagine you're building an application that needs to send email notifications. Instead of hard-coding the email sending logic directly into your application code, you could create a separate component that handles email sending. Then using DI, you can inject this component into any part of your application that needs to send emails.
So it's like having a dedicated mailroom that any department in your company can use to send letters, instead of each department having to handle their own mail delivery.
Exactly. And the beauty of DI is that you can easily swap out the email sending component for a different one if needed, without having to change the rest of your application code. This makes your application more flexible and maintainable.
That's really cool.
Yeah.
So DI is like a way to make your code more adaptable and reusable. What other features of Spring are essential for backend development?
Well, Spring MVC, or Model View Controller, is a core component that provides a robust framework for building web applications. It helps you organize your code into distinct layers, making it easier to manage and scale your application.
MVC sounds familiar. I
Oh.
think I've come across it in other web development contexts. How does it work in Spring?
In essence, MVC separates your application's logic into three interconnected parts: the model, the view, and the controller. The model represents your data. The view is responsible for displaying that data to the user, and the controller handles user interactions and updates the model accordingly.
Okay, that makes sense. So it's all about creating a clear separation of concerns within your web application, making it more organized and manageable.
Exactly. And Spring MVC provides a lot of helpful features that make it easier to build web applications, such as routing request handling and data binding.
That's awesome. And speaking of web applications, let's talk about RESTful web services. It seems like APIs are everywhere these days.
You're absolutely right. RESTful APIs have become the standard way for different applications to communicate with each other over the internet. And Spring makes it incredibly easy to build RESTful web services using Spring REST.
So if I'm building a backend system that needs to interact with other applications or provide data to a mobile app, understanding RESTful web services is essential.
Without a doubt, RESTful APIs are ubiquitous, and Spring provides a powerful toolkit for building them efficiently and securely.
This is all fascinating stuff, but it seems like we're just scratching the surface of Spring's capabilities. Is there anything else we should know about this powerful framework?
Oh, there's so much more. Spring Data simplifies data access by providing a consistent interface for working with various databases. Spring Security helps you secure your applications by providing authentication and authorization mechanisms. And Spring Boot makes it incredibly easy to get started with Spring by providing auto-configuration and embedded servers.
Wow, that's a lot to unpack. But it sounds like Spring is a one-stop shop for everything you need to build robust and modern Java backend applications.
It really is. And investing time in learning Spring will pay dividends throughout your career as a Java developer.
Okay, so we've covered Java fundamentals and delved into the world of Spring Framework. What's the next destination on our roadmap?
Well, building great backend applications requires more than just mastering a language or framework. It's about having a broader set of skills that go beyond the code itself.
I'm intrigued. What kind of skills are we talking about?
Things like understanding design patterns, testing and debugging, using build tools and version control systems, and knowing how to containerize and deploy applications.
That sounds like a whole other level of expertise.
Yeah,
Are these skills really essential for every Java backend developer?
absolutely. These are the skills that separate good developers from great ones. They allow you to build applications that are not only functional, but also well-designed, reliable, and scalable.
Okay, I'm definitely ready to level up my skills. But before we dive into these essential backend skills, let's take a quick pause. We'll be right back to explore this exciting territory in more detail.
Welcome back. So let's jump right back into it. We were talking about those essential back-end skills that can really elevate your Java development.
Right, we talked about that solid foundation with Java fundamentals and explored that power of the Spring framework. But now I'm eager to hear about those extra tools and techniques to build those exceptional backend applications.
Yeah, well, one of the most valuable assets in a developer's toolbox is a good understanding of design patterns. These are proven solutions to common software design problems, like architectural blueprints that have stood the test of time.
So instead of reinventing the wheel every time I encounter a design challenge, I can leverage these pre-existing patterns to create more efficient solutions.
Exactly. Design patterns provide a common language and a shared understanding among developers, making it easier to collaborate and build maintainable code. For example, the Singleton pattern ensures that you only have one instance of a particular class, which is useful for things like database connections or configuration managers.
Ah, I see. So it's about creating a single centralized point of access to a shared resource, preventing conflicts and ensuring consistency. That makes a lot of sense. What other design patterns are commonly used in Java backend development?
Oh, there are many. The factory pattern provides a way to create objects without specifying the exact class to be instantiated, making your code more flexible. The observer pattern allows objects to subscribe to events from other objects, enabling loose coupling and event-driven architectures. And the decorator pattern lets you dynamically add new functionality to objects without modifying their underlying code.
Wow, there's a whole world of design patterns out there. It sounds like mastering these patterns can really elevate the quality and sophistication of my code.
Absolutely, and it's an investment that will pay off throughout your development career.
Okay, so we've got our design patterns toolbox ready. What's next on our list of essential backend skills?
Well, even with the best design patterns, bugs can still creep into our code. That's where testing and debugging come in.
Right? I've heard the saying, code without tests is like a car without brakes. You might be able to get it moving, but it's going to be a dangerous ride.
That's a great analogy. Writing tests is essential for ensuring that your code behaves as expected and for catching bugs early on. There are different types of tests, such as unit tests, integration tests, and end-to-end tests, each focusing on a different aspect of your application.
So unit tests focus on testing individual components in isolation, while integration tests check how different components work together, and end-to-end tests simulate user interactions with the entire application.
Exactly. A comprehensive testing strategy that incorporates all these types of tests is crucial for building reliable and robust back-end systems.
And what about debugging? That's the process of tracking down and fixing those pesky bugs that inevitably make their way into our code, right?
Right. Debugging is an essential skill for any developer. It involves using tools and techniques to analyze your code step through its execution and identify the root cause of a bug. Integrated development environments, or IDEs, provide powerful debugging tools that can make this process much easier.
So it's like being a detective following clues and using specialized tools to solve the mystery of why our code isn't behaving as expected.
Precisely. And like any good detective, a developer needs to be patient, methodical, and persistent when debugging.
Okay, so we've talked about design patterns, testing, and debugging. What other essential back-end skills are on our agenda?
Well, let's move on to build tools and dependency management. These are essential for managing complex Java projects with multiple code files and external libraries.
Build tools sound intriguing. What exactly do they do?
Build tools like Maven and Gradle automate the process of compiling, testing, packaging, and deploying your Java code. They handle all the tedious and repetitive tasks involved in building and managing your project, freeing you up to focus on writing code.
So it's like having a dedicated construction crew that takes care of all the heavy lifting on our software project, leaving us to focus on the architectural design and creative aspects.
That's a great way to put it. And along with build tools comes dependency management. Most Java projects rely on external libraries and frameworks to provide functionality that we don't want to write from scratch.
Right. It would be insane to try to build everything ourselves from the ground up. We need to leverage existing libraries and frameworks to save time and effort.
Exactly. And that's where dependency management tools like Maven and Gradle come in. They help you define, download, and manage these external dependencies, ensuring that your project has all the necessary libraries to compile and run correctly.
So instead of manually hunting down and installing each library ourselves, We can use these tools to automate the process and keep our dependencies organized.
Precisely. It simplifies the process tremendously and prevents version conflicts and other headaches.
That's a huge time saver.
Mm,
Now, speaking of teamwork and collaboration, I've heard that version control is a must-have skill for any developer.
you're absolutely right. Version control systems like Git are indispensable for managing code changes, collaborating with other developers, and tracking the history of your project.
I dabbled in Git a bit, but I'm still a bit intimidated by all the commands and concepts. Can you break down why version control is so essential, especially for back-end development?
Sure. Imagine you're working on a feature for your backend application and you accidentally introduce a bug that breaks everything. Without version control, you'd be stuck trying to manually undo all your changes, which could be a nightmare.
Ouch, that sounds painful. So version control is like having an undo button for your entire project.
That's one way to think about it. Git allows you to track every change you make to your code, creating a detailed history of your project. You can easily revert to previous versions if needed, compare different versions to see what changes were made, and even create branches to work on new features in isolation without affecting the main code base.
That's amazing.
Yeah,
It's like having a time machine for your code, allowing you to explore different timelines and revert to previous states if things go wrong.
exactly. And it makes collaboration with other developers much smoother. Git allows multiple developers to work on the same project simultaneously merging their changes together seamlessly.
So it's like having a shared workspace where everyone can contribute their part without stepping on each other's toes.
Precisely. Version control is an essential skill for any developer, and Git is the industry standard. Investing time in learning Git will pay off immensely throughout your career.
Okay, we've got design patterns, testing and debugging, build tools, dependency management, and version control under our belts. Is there anything else we need to add to our essential backend skills toolkit?
There's one more crucial area that's become increasingly important in the modern development landscape: containerization and deployment.
Containerization sounds vaguely familiar. Is it something to do with shipping containers?
Well, not exactly, but the analogy is helpful. Containerization using tools like Docker allows you to package your application and all its dependencies into a self-contained unit called a container. This container can then be run on any platform that supports Docker, ensuring consistency and portability across different environments.
So it's like taking your entire application with all its libraries and configurations and putting it into a portable box that can be easily transported and run anywhere.
That's a great way to visualize it. Containerization makes it much easier to deploy applications consistently across different environments, from development to testing to production. It also simplifies the process of scaling your application by allowing you to easily spin up multiple containers to handle increased traffic.
That's pretty cool. So it's like having a pre-configured, self-contained environment for your application that you can easily deploy and scale as needed.
Exactly. And containerization goes hand in hand with deployment, which is the process of getting your application up and running on a server or cloud platform.
Right. Deployment is like the final step in the software development lifecycle, where we take our code from our development environment and make it accessible to users.
Precisely. And with the rise of cloud computing, deployment has become much more sophisticated and complex. We now have cloud platforms like AWS Azure and Google Cloud that offer a wide range of services for deploying, managing, and scaling applications.
This is where DevOps practices come into play, right? I've heard DevOps mentioned a lot, but I'm still a bit fuzzy on what it actually entails.
DevOps is all about bridging the gap between development and operations, fostering collaboration and automation throughout the software development lifecycle. It involves practices like continuous integration and continuous delivery, or CI/CD, which automate the process of building, testing, and deploying code changes.
So instead of having separate teams for development and operations working in silos with manual handoffs, DevOps promotes a more integrated and automated approach.
Exactly. CI/CD pipelines automate the process of building, testing, and deploying code changes, allowing for more frequent and reliable releases. This means you can get new features and bug fixes into the hands of your users faster and with less risk.
That sounds incredibly efficient.
Yeah.
But isn't setting up and managing these CI/CD pipelines quite complex?
It can be, but thankfully there are tools and platforms that simplify the process. Cloud platforms like AWS and Azure provide managed CI/CD services that make it easier to set up and manage your pipelines.
This is all starting to sound very advanced, but I'm excited to learn more about how containerization deployment and DevOps can help me build and deploy more sophisticated Java backend applications.
Excellent. These are essential skills for any modern Java backend developer, and they open up a whole world of possibilities for building and delivering software efficiently and reliably.
Well, we've covered a lot of ground today, from design patterns to containerization. Is there anything else we need to explore on our journey to becoming a Java backend developer in 2025?
There's one final and perhaps most important aspect we need to discuss: continuous learning.
Ah, yes. The tech world is constantly evolving, and Java is no exception. How can aspiring Java developers keep up with all the new technologies and trends? It seems overwhelming.
It can feel that way, but continuous learning is the key to staying ahead of the curve. There are countless resources available both online and offline that can help you expand your knowledge and skills.
Such
Well, online learning platforms like Coursera, Udemy, and Pluralsight offer a wide range of courses on Java and related technologies. Conferences and meetups are great ways to connect with other developers and learn about the latest trends. Blogs, podcasts, and online communities provide valuable insights and perspectives. And open source projects offer opportunities to contribute to real-world software and learn from experienced developers.
Wow, there's a whole ecosystem of learning resources out there.
Yeah.
Sounds like staying up to date is all about being proactive, curious, and engaged with the Java community.
Exactly. Embrace the spirit of continuous learning, and you'll be well equipped to navigate the ever-changing landscape of Java backend development.
This has been an incredibly insightful journey so far. We've covered so much ground, from Java fundamentals to essential back-end skills and the exciting world of cloud and DevOps. But before we wrap up our deep dive, let's take a quick pause to process all this valuable information. We'll be right back to discuss the final piece of the puzzle: continuous learning and the importance of staying ahead of the curve in the fast-paced world of Java back-end development. Welcome back to our deep dive into becoming a Java backend developer in 2025. We've talked about building a strong foundation with Java, those frameworks like Spring and all those essential backend skills. But now let's talk about how to stay ahead in this ever-evolving field.
Yeah, it's kind of like being a lifelong student. The moment you think you've arrived in tech, something new pops up.
Yeah,
But that's also what keeps it exciting.
totally. So for someone aiming to start their Java career in 2025, what are some smart ways to approach continuous learning?
Well, first, I'd say don't get overwhelmed by the sheer volume of information out there. You don't need to know everything. Focus on building a solid understanding of core concepts and then branch out from there.
That makes sense. So start with the fundamentals we talked about, like Java syntax, OOP,
Right.
the collections framework, and make sure those are rack solid.
Exactly. Once you've got that foundation, explore frameworks like Spring and delve deeper into specific areas that interest you. Maybe you're fascinated by microservices or cloud-native development, or perhaps you're drawn to big data and machine learning.
That's where the real fun begins, right?
Mhm.
Specializing in a niche that aligns with your passions. But how do you actually go about learning these new technologies and keeping your skills sharp?
Well, there are tons of resources available. Online learning platforms like Coursera, Udemy, and Pluralsight offer amazing courses on Java and related technologies. Many of them are even free or very affordable.
Oh, that's great. I love the accessibility of online learning.
Yeah.
It's like having a world-class education at your fingertips.
Yeah.
But is it enough to just watch videos and read tutorials?
Yeah. While online learning is fantastic, it's important to get hands-on experience too. Build personal projects that challenge you to apply what you're learning. Contribute to open source projects to collaborate with other developers and learn from their expertise.
That's a great point.
Mm.
It's one thing to understand concepts in theory, but it's another thing entirely to put them into practice and build real-world applications.
Absolutely. And don't underestimate the power of connecting with other developers. Attend conferences, join online communities, and participate in meetups to share knowledge, learn from others, and stay inspired.
It's all about being part of the community, right? Surrounding yourself with people who are passionate about Java and technology and who can support you on your learning journey.
Exactly. The Java community is incredibly vibrant and welcoming, and there are countless opportunities to connect with like-minded individuals both online and offline.
This has been an amazing deep dive. We've covered so much ground, from the foundational building blocks of Java to the advanced skills and continuous learning mindset needed to thrive as a back-end developer in 2025.
I always say the journey of a developer is never truly finished. There's always something new to learn, some new challenge to tackle. And that's what keeps it exciting.
So true. And for all of you out there ready to embark on this exciting journey, remember to embrace the challenges, celebrate your victories, and never stop learning.
Now, before we sign off, I'd love to hear from you. What aspect of Java backend development excites you the most? What are you most eager to learn? Share your thoughts in the comments below.
And if you enjoyed this deep dive into the world of Java backend development, be sure to subscribe to the Pragmatic Reviews YouTube channel for more insightful content like this. Hit that like button, share this episode with your fellow developers, and we'll see you in the next deep dive.